This is a short video on Lab 5, Resonance in LRC circuits. And I've tried this lab at least 6 times, maybe 7, and something is always going wrong, but we'll see if we can get it right this time. There's a fairly long introduction in the manual explaining the circuit. You definitely want to read that before you get to the lab. Answer the pre-lab questions as usual. The circuit layout in this case is not so simple. There's an L, R, and C that you wire together in series and connect it to the wave generator on the scope. But then we also have this 3-channel amplifier, and those 3 channels are going to be measuring the voltage across the inductor, resistor, and capacitor. I've kind of put in the values here: the 34 millihenry inductor, 1 k ohm resistor, and 1 nanofarad capacitor. The output from the 3-channel scope goes into the 3 channels of the scope, the first 3 channels, and the output of the wave generator also connects up and goes into channel number 4. So we recommend when you're wiring up this circuit, first you get a whole bunch of coaxial cables. You need, looks like about 5 or 6 of them, and also a whole bunch of banana connectors and some additional BNC to banana adapters and other things. So here's our, you see I've got some red and black banana cables, also a spare yellow one just in case we need it, some T connectors for the BNC cable, some adapters, and a connector that goes from BNC to banana, and also a bunch of coaxial cables. And here are the main components that you'll be putting together. You can see our familiar coil will be going between the 1500 and 0 pins here on the end. You'll need the LRC board, and it's important to realize what the different components are, and you should see on your desk a sheet that has a photograph of the board, and it's been labeled with the values. We'll be using the 1 nanofarad capacitor, which is looking at the sheet, that's over here. And we'll also want to use the 1 k ohm resistor according to the diagram. And there's actually a couple of them. There's one here and one up here. So that's this one, brown, black, red, for example, or that one up here, brown, black, red here, or brown, black, red right there. Of course, we also have our oscilloscope, and there's the 3-channel amplifier. And you might find it useful also to have an Lcr meter, which will let you double check, say that you've got the right components here before you wire them up on the RC board. All right, I've got the camera set up on the stand here, and you should be able to see the RC board, the inductor, the scope in the background, all 4 channels, and up here on the side, I guess, is the wave generator output, which we're going to be connecting to. And also you can see the RC board circuit here and the 3-channel amplifier on the right. So let's start wiring up the circuit by connecting the L, the R, and the C in series, and we'll connect it to the wave generator. So grab a coaxial cable, and first thing is to, if you like, make sure everything is off, but hook up to the wave generator, and then we need to go to a T. So here's the output. You'll notice it doesn't go together. We also need an adapter here, and now we can go to this T. And if you look at the circuit diagram, you'll see that one of these ends of the T will go off to channel 4 on the wave generator. That will allow us to keep track using the scope of the output from the wave generator. And then the other output will go off to connect across our LCR circuit. So here I've got now the T connected in. I've got another end of the BNC. And we need to go to a banana plug to do that. So here I'll just, again, put an adapter in. And now I'm going from BNC to a banana plug. All right, so we have that connector, BNC connector, coming out of the wave generator. And if you check your circuit schematic, you will see the positive lead is supposed to go off to the positive lead on the capacitor. And so let's hook up a red banana plug and go over. Here's our 1 nanofarad capacitor. If you check the sheet there, and the black lead is going to go over to the black lead on the inductor. We'll go to that 1500 pin. Right, like that. So now we have the wave generator hooked up, one end of the capacitor and the other end to one end of the inductor. But of course, there's no connection between that inductor and the capacitor. So let's wire that up. So let's take a red banana plug, and we can go from the red terminal on the inductor over to the red terminal on this 1 k ohm resistor right here, which you can identify on the board. And then the output of that resistor is on this end. That has to go over to the output on the capacitor. So that's going to jump from here to this lead up here. And of course, at that point, it goes from the capacitor over to, through the capacitor and then back to the red terminal. So if you follow from the wave generator, splits, goes one terminal over here to 4, which are measured. The other goes to these, this BNC banana adapter. Positive current goes to the capacitor, goes through the resistor, goes through the coil, and goes back to this point. So that's a closed circuit. We're only partly done with the circuit, though. We also need to hook up this 3-channel amplifier. So we're actually measuring these voltages across the R, L, and the C. And so let me do that now. The easiest way is to actually hook up the outputs, which are these BNC connectors, to the oscilloscope. And let's start by grab a BNC connector. And here's channel 1 output from the 3-channel amplifier. Of course, we don't have anything going to the input yet, but we'll fix that in a minute. That's going to go over to channel 1 here. Channel 2, another BNC connector to channel 2. And channel 3 to channel 3. And I've left the scope on here and actually have the amplifier on also. The voltages are low here, so there's really no danger in doing that. You kind of see what's happening as I go along. Okay, again, there's no inputs going into this 3-channel amplifier, but we do have the wave generator hooked up to channel 4, so actually we can see the channel 4 is displaying something now. I'm going to just move this down here. That's the drive voltage. All right, so all we need to do now is hook up the inputs of the 3-channel amplifier so that we're measuring the voltage across the different components. Let's start with channel 1. That goes across the inductor. Grab a red and black banana plug, put them in here, and I'm going to twist these together, just trying to keep some order in this, and come over, hook that black and red. So that is now channel 1, and we're not seeing much voltage across here. Not worried about that yet. We haven't really done anything with the source. Let me get another pair of red and black banana plugs for channel 2, and that's going to go across the resistor. Let's go again, red and black, and finally channel 3, we're going to go across the capacitor. Here is black lead into channel 3 input, red lead, and again here's the capacitor, red and black. Okay, so now we've got all 3 channels hooked up, and let's take a look at what the scope is doing. All right, so I've moved the camera so we can kind of zoom in and see the scope and its controls. The circuit is pretty complicated, but we're all set here. And so what you want to do is make sure that you're turned to the wave generator and that you've pushed the frequency knob so that when you turn the main control knob, you can sweep the frequency of the source. Also, you want to make sure the wave generator is turned to make a sine wave. And I've got the amplitude set at 1 volt peak to peak. Let me adjust the horizontal control here so you can see a little bit better the driving input wave. This is then the 3 channels here. So the upper highest one, yellow, let me just move it up a little bit further by using this knob here. That's the voltage across the inductor. There's voltage across the capacitor. And that blue one is the voltage across the resistor, channel 3. Actually, got that wrong. The top one is the voltage across the inductor. The green one is the voltage across the resistor. And the blue one is voltage across the capacitor. And you can see we're at a fairly low frequency here, about 9 kilohertz. And the voltage across the capacitor is about the same as the drive voltage. Actually, you can see it's a little bit higher. But anyway, we'll come back to what's going on there. Whereas the voltage across the resistor and the inductor is pretty low. So let me just sweep the frequency, starting at about 9 kilohertz and increasing it. And you can see that the wave length or the frequency is increasing. It's getting less distance between them. But you can now see also that the inductor and the resistor are showing substantially larger voltage. I'm now at about 14, there's 15, 16. You can see these are climbing up. You can also see the voltage across the resistor is climbing up. Across the capacitor is climbing. Let me adjust channel number 3 a little bit and slide that up to fill in that slot. And it's now at 2 volts per division, whereas the other channels, first channel actually is at 5 volts. Let me increase that, that's 2 volts. They put all the channels so that they're at 2 volts per division. So you can really see what's going on here a little bit better, and you can see that I just changed that last channel, and it's not happy with the triggering. So I'm gonna slide the trigger up a little bit and get that to cooperate a little bit better. All right, so Now all 4 channels are showing 2 volts per division. You can see that the voltage across capacitor is largest, voltage across inductor is second largest, the resistor is small, and we're again at about 14 kilohertz. So go back to the wave generator, about 17 kilohertz. Let me sweep the frequency a little bit more. That was a big jump there. It's quite a bit larger, so somewhere in there, and I'm gonna push this knob, and that allows for a finer control of the frequency when I sweep it. And you can see somewhere right in about here is where everything gets large, or as large as it's going to be. The inductor and capacitor show the largest voltage. The resistor shows its largest voltage, all in this range, somewhere around 19, looks like 19 kilohertz in this case. And what you'll do is at a whole range of frequencies near that resonance, you'll find the resonance, and at frequencies near that resonance, you'll map out how large the voltage is in each one of these channels. And also the macro that we have will keep track of the phase for you and plot that out in the end. So anyway, that's a quick look at the circuit, and if you go much higher in frequency, you'll see that the response dies down very quickly. And of course, if you go much lower in frequency, you also see that resonance or the response disappears. So it's a quick look at the LRC circuit, and that is lab 5.